Hello everyone, welcome to this next question on classical mechanics. In this question appeared in December 2018 consisting of 4.75 marks. The question says there is a point mass of mass m. This mass is given to us, that means this mass is fixed, which is attached to a massless rigid rod of length a, and we have a rod whose one side this mass is attached. The other end of the rod is made to move vertically such that its downward displacement from the origin at time t is given by this curve. So let us see what they are saying. They are saying we have the situation. This is some plane, right? This is x-axis and this is say z-axis, and this is some rod, and this rod say makes an angle theta with the given z-axis, and at this end we have the mass m, right? So now can we see this displacement? What is this displacement? This is given by the length of this rod is a, so this displacement over here, the distance y z, this is given by a cos of theta. So now this rod, this can move downwards in this direction, and they are saying this curve defines the downward direction of this rod. So it could be displaced like this or like this, and similarly we can have different directions, and it is given by z0 cos omega t. Therefore, the next thing that they are saying, the mass is moving in a fixed plane and its position vector at time t is given by this thing. So the position vector here, the r vector of the mass, this is given by a sine theta and then z, which is z0 cos omega t plus a cos of theta. Now theta is a function of time, remember that. So this is the position vector of the given mass. Now they are asking what is the equation of motion for this point mass m. So for this point mass m, we need to find the equations of motion. So you see the equations of motion, they are given by the Lagrange equations. So what are they? And we have only one independent variable over here, this theta. Therefore we only have one Lagrange equation, and it is del L by del theta minus d dt of del L by del theta dot. So here the independent variable is time, theta depends upon time, and this L is a function of theta, theta dot and t. So L is a function of theta, theta dot and t. So we need to compute this in order to calculate the equation of motion given in the question. So for this calculating this thing, we should know what is L. The Lagrangian L is given by T minus V, where T is the kinetic energy and V is the associated potential energy. So let us calculate these for the given system. So you see the potential energy, this is given by this expression the potential energy is given by mg into h, where h is the respective height of the object, that is mass in this case, from some reference point. So you see the total height is given by a cos theta plus z cos omega t, but it is given in the downward direction, so we'll take it to be minus of mgh. So the potential energy, which is V, that is given to be mg minus mg into the sum of these. So we have a cos of theta and we have minus mg into z0 cos omega t. So this is our potential energy. Now next let us calculate the associated kinetic energy. It is calculated using the expression half mv square. Now in order to calculate v square, we should derivate this position vector. So this position vector is vector v, velocity vector v, is calculated by differentiating this position vector with respect to time. So we can differentiate it. A is constant, so it would only be a, and then the derivative of sine theta would be cos theta, and then the derivative of theta would be theta dot. And then for the second term we had z0 as constant, the derivative of cos is minus sine omega t and into minus omega. So we have minus omega z naught sine omega t, and then for the second term we have a as constant. The derivative of cos is minus sine of theta into d theta, so that would be theta dot, the derivative of theta with respect to time. So this is our v. So what is v square? V square is vector v dot product with vector v. So we have to take the dot product of this term. So we need to calculate v dot v. So it would be dot product of this term with this term, a cos theta theta dot, and then minus omega z naught sine omega t, and plus a sine theta into theta dot. So when you take the dot product, this is the vector with I cap, this is the vector with j cap. So you know, when you take the dot product, only the terms with similar direction they are preserved. So I dot I would simply be a square cos square theta into theta dot square. This is the first term, and the second term would be the square of this quantity, the second quantity. So it would be omega square z naught square sine square omega t, the square of first term, then the square of second term, a square sine square theta into theta dot square, and then plus 2 times the product of these two terms. So we have omega z naught a sine omega t into sine theta into theta dot. So this is v square, and what is t? T is equal to half into m into v square. So that means we have t is equal to 1 by 2 m into this whole quantity. So now what would be our L? L would be calculated as t minus v. So our L, that would be t minus v. So this was our t minus our v. And what is v? V is this quantity. So minus and minus, it would become plus mga into cos of theta, and then plus mg into z naught cos omega t. So this is the corresponding Lagrangian function. So now in order to calculate these equations of motion, we need to differentiate this Lagrangian once with respect to theta, and then we have to differentiate it with respect to theta dot. So let us do it. So the derivative of this L with respect to theta, that would give you this first term, this contain theta. Before that, if you see these two terms, you have a square theta dot square theta dot square. So they would combine and they would become simply a square theta dot square into half m, because cos square theta and sin square theta, they would add up to give you 1. So now we can take its derivative with respect to theta. There is no theta term over here in the first term, so that would simply be equal to 0. In the second term, we also do not have any theta term, that would be 0. In this third term, we have theta, so the derivative of sine theta would be cos theta, and all the factors as such, 2 omega z naught a into theta dot sine omega t as such, and the derivative of sine theta is cos of theta. In this we have theta, so it would be minus mg a sine theta. That's it. So now let us calculate del L by del theta dot. So in the first term we have theta dot, so it would be m a square theta dot. In the second term there is no theta dot. Then in this we have theta dot, so it would simply be plus 2 omega z naught a sine omega t into sine of theta, because all these terms, they will be constant when you differentiate partially with respect to theta dot. Here there is no theta dot, here there is no theta dot. So these are the terms available with you. So now next thing, what you have to do, you have to take the derivative for this term. So it would simply be the derivative of this term with respect to time. So let us calculate that. So m a square, that is constant, the derivative of theta dot with respect to t, that would be theta double dot. Dot here means derivative with respect to variable time. Plus in the second term we have 2 omega z naught a as constants. Here it is t and here it is theta, which is a function of time. So we have to apply the product rule over here. So it would give you the derivative of sine omega t would be omega cos omega t sine theta as such, and then sine omega t as such, and then the derivative of the sine theta would be cos theta, and then the derivative of theta with respect to time would be theta dot. Why? Because we are taking the complete derivative now with respect to theta. So now we have this term, we have this term, so we can subtract these two terms. So let us see what do we get from here. Now we have to solve this equation, so we have to subtract this term from this term. So we would have 2 omega z naught a into sine omega t cos theta into theta dot minus mga sine of theta, and then minus of this whole quantity. So it would be minus m a square theta double dot minus 2 omega z naught a into omega cos omega t sine theta plus sine omega t cos theta into theta dot, right? So this is 2 omega z naught a sine omega t cos theta theta dot. So can we have, do we have some term of this kind? Yes, we do. So this term cancels with this one. So let us see what we are left with. So we are left with minus mg a sine theta minus m a square theta double dot and then we should we had minus 2 omega z naught a into omega again omega square cos omega t sine theta, that is equal to 0, right? So now okay, wait, over here when we differentiated L partially with respect to theta, so here it should also, this term is also multiplied by half m. So here in this term I should have, so this 2 cancels with 1 by 2 and we should have 1 m over here. Similarly in this term also we should have this half into m. So this 2 cancels with this 2, so we are left here with m, right? So this is just a small calculation mistake. I think you can overcome it, no problem with that. So let me see where do I have to make the modifications. So here it would be m instead of 2, right? So here also we should have this m instead of 2. So now just simplify the equation. We can take the negative common, m common from every from both the sides, and then a common. So we are left with a theta double dot, and then we have g sine of theta plus over here we have omega square z naught cos omega t into sine of theta, that is equal to 0. So this is the equation of motion of the corresponding mass. So let us now match this with the given 4 options. So these are the options given to us. So can you see which equation matches with this one? So if we take sine theta common from here, we are left with g plus omega square z naught cos omega t. So this term into sine theta and plus a into theta double dot. So this is the option A. Therefore, this option A is the correct option for the given problem. Well, this is a quite lengthier problem, but it is worth solving it for 4.75 marks, and we can surely reach at the solution. if we just know the simple formulas of this Lagrangian and this Lagrange equation. So that is it for this video. Thank you for watching.